Okay, so today we're going to be working on radical equations. So solving for x when there's a radical involved. Okay, so the first step is isolate the radical on one side of the equation if we can. We have problems like this where we have two of them, but if we can, we want to get the radical on one side of the equal sign by itself. And then we're going to raise each side of the equation to a power equal to the root right here. So for this one, the root is 2, so we would square everything to eliminate the radical. And then we would solve for x, just like we would any regular equation. With radical equations, we always have to make sure that we plug it in afterwards, because sometimes we'll get extraneous solutions. And this is a number that doesn't satisfy the original equation, even though we've solved for x and it is that number. So these we always have to make sure that whatever we get for our solution, we go back and plug it in and make sure it's a true statement. Alright, so for example 1, again, we want to isolate the radical on one side of the equation if we can. So for this one, here's our radical. We want to get it by itself, so we need to get rid of the 4. What is the operation being done here? Adding 4. So we want to do the opposite, which is subtract 4 from both sides. So when we subtract 4 from this side, let me zoom in some, they will cancel out, and we'll get square root of x plus 2 equals, and then 7 minus 4 would be 3. And now here is x. We got to get it by itself on this side. So the first thing we need to get rid of is the square root. We couldn't do minus 2 because this is not 2, this is square root of 2. So again, the first thing we want to get rid of is the radical. And to do that, we have to do the opposite operation, just like right here. So what's the opposite of taking the square root? That would be squaring something. So we're going to square both sides. The square root of x plus 2 times the square root of x plus 2 will just be x plus 2. That was the point of doing that, so we can take away the radical. And then 3 squared will be 9. And now it's easy to see that from here, all we have to do is subtract 2 from each side to get x by itself, so x equals 7. Or we think x equals 7. We have to plug these back in. So I'm going to do my check work over here. So I plug it back into the original, so instead of square root of x plus 2, it'll be square root of 7 plus 2 plus 4 equals 7. And I don't want to change anything or subtract anything. I just want to make sure this side, when worked out, equals 7, equals this side. So this would be the square root of 9 plus 4 equals 7, and the square root of 9 is 3 plus 4 equals 7, and 3 plus 4 does equal 7. So this is the solution. It checks out. Alright, on number 2 on this side, we have 2 radicals, so we won't have to worry about getting it by itself. We can go ahead and move on to the next step, which would be square rooting both sides. Again, we couldn't isolate the radical on one side because we have 2 of them. That's why we're just jumping into squaring both sides. The reason we square both sides is because this root is 2, so if we square both sides, it'll get rid of the radical. Okay? Alright, on this side, x minus 12 squared root of x minus 12 times square root of x minus 12 is x minus 12. But on this side, we have how many terms? 2. So this is a binomial. And we know that when we multiply 2 binomials, or square it, we have to full. So I'm going to come over here and full out 2 minus square root of x. Okay, so my first terms, that's going to give me 4. Outer terms is 2 times negative square root of x, so that's negative 2 square root of x. Inside terms gives me negative 2 square root of x. And then my last terms, negative square root of x times negative square root of x makes a positive x. And now I combine my like terms, so I would have 4. These 2 are my like terms because they have the same root and same thing underneath. So I combine their coefficients, and that would make negative 4, because negative 2 minus 2 is negative 4, square root of x plus x. So that's what's going to be on this side. 4 minus 4 square root of x plus x. And now we're trying to get what by itself? We're trying to solve for x, okay? So the first thing I'm going to do is try to combine like terms. I know I can combine these x's. I can't do this one because it's underneath the radical, but let's go ahead and combine these. Okay, and then now from here I'm going to combine my x's. So there's two x's. These are like terms. So if I move this one over here with this x, I'd have to subtract it from both sides. And when I do that, these x's on both sides will cancel out because one's negative, one's positive. So if I bring down everything else, I have negative 12 equals 4 minus 4 square root of x. The 12 and the 4 are like terms. So I'm trying to get x by itself, so I'll move the 4 over here by subtracting. So I get negative 16 equals negative 4 square root of x. Now to get x by itself, I need to divide everything by this negative 4. So I'll get 4 equals square root of x. And now to get the x by itself, I just square both sides. So that was 16 equals x. Okay. Alright, so now I'm going to plug it back into the original to make sure it's not extraneous solution. So I'll have square root of 16 minus 12 equals 2 minus square root of 16. So on this side, I'll have square root of, this would be 4 equals 2 minus square root of 16. Square root of 4 is 2. This would be 2 minus square root of 16 is 4. So this would be 2 equals negative 2, which is not true. So this 16 is an extraneous solution, so we would put no solution for this one. So again, if it doesn't work, 2 does not equal 2, it'd be no solution. Alright, next one, number 3. So this one, again, our radicals are on both sides, so we can't isolate it really, or they are isolated on both sides. So we will just start by solving for a. So we need to get rid of the radicals, so we would square both sides. And when we square both sides, all that does is remove the radical from each one. So this will be 7a minus 2 equals a plus 3. I'll combine my a's first. So I will move this a over with this a. So I'll do the opposite sign. So minus a, minus a. So on this side I'll have 6a minus 2. These a's will cancel out. Equals 3. And now here's a. Trying to get it by itself. So I got to move this 2 over by adding it. So I get 6a equals 5. And now I divide both sides by 6. I get a equals, and I'm going to leave this as a fraction, 5 over 6. And now we have to check it. So I'll do my check work over in this section. And we're going to plug in 5 over 6 to the original for a in both sides. So I get square root of 7 times 5 over 6 minus 2 equals square root of 5 over 6 plus 3. Alright, let me go ahead and multiply these. So 7 times 5 is 35. Our denominator would be 6 minus 2 equals square root of 5 over 6 plus 3. Well, we know we cannot add these or subtract them unless they have the same denominator. So I'm going to leave 35 over 6, and now this denominator needs to be 6 instead of 2 over 1. So if I change the 1 to a 6, I multiply it by 6. So I have to multiply the top by 6 also and get 12. This over here will be 5 over 6. Same thing, instead of 3 over 1, I want something with 6 on the bottom so I can add these. So I multiplied the bottom by 6 to get 6. So I multiply the top by 6 and I get 18. And now I just simplify. So I keep the same denominator, 6. On top, that would give me what? No. Okay. That would give me 23 over 6 equals, and then 5 plus 18, that's 23 over 6. And the square root of 23 over 6 does equal the square root of 23 over 6. So our answer is 5 over 6 is correct. It's not extraneous. Alright, moving on to the next one. So, again, I have two radicals. I can't isolate it because this one is either got to be on this side or this side. So, I'm going to skip right into squaring it. So, if I square both sides, I know I'll get x minus 3 on this side, but on this side there's two terms. There's square root of x plus 4 and negative 1. So, I have to fold it. I'm going to zoom out and do it on my whiteboard because I don't have enough room. So, we are folding square root of x plus 4 minus 1 times square root of x plus 4 minus 1. Alright, so my first terms when I multiply them together, it's just going to give me x plus 4. The radical goes away. My outer terms, so square root of x plus 4 times negative 1 is just itself, with a negative out front. Same thing for my inside terms. My last term is negative 1 and negative 1. That's going to make a positive 1. And so if I clean this up, 4 and 1 I can combine, right? That's going to make 5. This x does not have any like terms, so plus x. These two are like terms because they have the same root, same thing underneath them. So I combine their coefficients. So negative 1 minus 1 will give me negative 2, square root of x plus 4. So that is going to be my result when I fold it. And go ahead and write that on your paper. I'm going to write it on mine too, then I'll have to erase it. Okay. Alright, so here it is on my paper. Let me zoom in. Alright, now I'm going to combine my like terms, starting with my x's. So here's my x's, and if I combine them, meaning if I subtract 1 from each side, notice how they'll cancel out. So I have negative 3 equals 5 minus 2 square root of x plus 4. And this 2 is with this radical, so I can't combine it with like the number 5. I couldn't do 5 minus 2 is 3. Square root of x plus 4. These are not like terms. But negative 3 and 5 are like terms. So I can subtract 5 from each side. I'll get negative 8 equals negative 2 square root of x plus 4. Trying to get x by itself, so from here I'd have to get rid of that negative 2 first. So let's divide everything by negative 2. And we'll get 4 equals, these 2's would cross out because negative 2 divided by negative 2 is 1. So equals square root of x plus 4. Got to get rid of that square root, so I square both sides. I get 16, because 4 squared is 16, equals x plus 4. And then finally I subtract 4 from both sides. I'll get x equals 12. Alright, and I'll do my check work over here. Kind of running out of room. So if I plug 12 back into the original to see if it works, I'd have square root of 12 minus 3 equals square root of 12 plus 4, and then a minus 1 on the outside. Oops. So 12 minus 3 is 9, square root of 9 is 3. 12 plus 4 is 16, square root of 16 is 4. And 3 does equal 4 minus 1. So our solution is 12. It's not extraneous. Okay. Next one, this one's just a little bit different because it's an exponential form, but that's fine. We don't have to change it. The first thing we want to do is get this by itself because this is a radical even though it's an exponential form. So first let's move that 4 over to try to get x by itself. So add 4 to both sides. And I get 6x minus 3 to the 1/3 equals 4. And now I can get rid of this 2 by dividing everything by 2. So those cancel out to 1. So I get 6x minus 3 to the 1/3 equals 2, because 4 divided by 2 is 2. And then this is the cube root, taking the cube root. So we'd have to cube everything, or if it's an exponential form, we know that if we multiply this by its reciprocal, which is 3 over 1, we'll get an exponent of 1, which is what we want. We want to get rid of that fraction radical. So we're going to multiply or raise everything to the 3rd power. So when we raise this to the 3rd power, we multiply our exponents. 3 times 1 over 3 is going to give us 1, so 6x minus 3 is what we're left with. And then 2 raised to the 3rd power, which is 2 times 2 times 2, would give us 8. And now it's an easy equation. We add 3, so we'll get 6x equals 11. Divide, and we get 11 over 6. And now we plug it back in to see if it works. So we'll have, I'm going to do check work over here, 2 times 6 times 11 over 6 minus 3 to the 1/3 minus 4 equals 0. So 6 times 11 over 6, the bottoms will cancel out. 6 divided by 6 is 1, so you're left with 11. So it's 2 times 11 minus 3 to the 1/3 minus 4 equals 0. 11 minus 3 would be 8. Alright, 8 to the 1/3 power is the same thing as the cube root of 8, which we know is 2. So this is 2 times 2 minus 4 equals 0, which we know is going to work out. Alright, last one. So we got to get this by itself first, z. So we're going to add 1. So we'll get 4z minus 1 to the 1/5 power equals 3. And then we raise everything to the 5th power on the inside to get rid of this. So we'll get 4z minus 1. And 3 to the 5th power is going to be 243. We add 1. And then from here we divide by 4. And we would get z equals 61. So now if we check it, we'd have 4 times 61 minus 1 to the 1/5 minus 1 equals 2. So 61 times 4 is going to be 244. 244 minus 1 is 243. 243 to the 1/5 power is going to be 3, and then 3 minus 1 is going to be 2, so it checks out.